All right, got a late night one for you. So what kind of dinosaur loves to sleep? All of them. All right. So we've got it's a bit of a review, uh, but it's about tangents and normals, but including kind of like your exponentials. Similar to your other functions, you'll be asked to find tangents and normals of exponential functions. Okay, the function that we're going to work with for today is y equals e to the 2x. So let's take a look at this question. Let's take a note here. Your graph is going to look a little bit like this. Okay, it's still going to cut at 1, and it's an exponential. How do I find the gradient of the tangent at that point? The way that I'm going to do that is gradient of the tangent means I need my y dash. So differentiating this, I'll get 2e to the 2x. And at x equals to 1, gradient of my tangent is now 2e 2 times 1, which is just 2e squared. So there you go. There's your gradient of the tangent. I'm going to continue writing in blue, so it's a little bit easier to see what's what. Okay. Now, how do I find the gradient of the normal? Now, the easiest way to find the gradient of the normal is we remember that m1 times m2, these two gradients, if they are perpendicular, they'll equal to -1. So in other words, in this case here, I'm going to solve and find the negative reciprocal. My gradient of my normal should be -1 on 2e squared. Okay, we take the negative reciprocal. If you need to, you can go ahead and solve. 2e squared times, our second thing should equal to -1, and that's where you'll end up. Okay, so that there will be our gradient of the normal. Okay, now how do you find the equation of the normal? Hopefully you recognize that we need a point gradient formula. Okay, now I know if x equals to 1, y is also going to equal to e to the 2. Okay, so e to the 2x, and where x equals to 1, it'll be y equals e to the 2. Okay, so there's our point, and our gradient is here, right? Point is here, gradient is here. Now, just a little touch on the point. The point you always sub back into the original equation. Okay, so once you sub back into the original equation, you've got your point, you've got your gradient. Go straight for it. Y minus y1 equals to m bracket x minus x1 there. And so to make it kind of, I guess, nice, I'm just going to plus the e squared here, and I'm going to leave that as it is. There's the equation of my normal at the point x equals to 1. Okay, so if I go back to this tiny little diagram here, the gradient of or the equation of my normal will kind of be, I guess, that guy when x equals to 1. Okay, now I haven't drawn a great job here. Oh, maybe I'll do this here. Find the area of the triangle bound by the normal and the x and y axis. Okay, so I'm going to draw a small little diagram so you can kind of see a bit better what's going on. There's my exponential. That's y equals e to the 2x. Now I know that at x equals to 1, I'm going to get a tangent that looks a little bit like this. But then my normal, which I'll do in green, is going to be kind of like this guy here. And what I'm hoping for is once I do this, I can recognize that there is going to be 1e squared, 1e squared. And it's also going to be, this equation is going to be y equals to -1 on 2e squared bracket x minus 1 plus e squared. Oof. Okay. Now to find the area of the triangle, I'm going to highlight it in green so you can see. I'm finding the area of this triangle here. Okay, so as you can see, a diagram is very helpful to see. Now I know that the area of a triangle is going to be half times base times height. But the issue is I don't know the base and I don't know the height. But what's going to give me my base is the x-intercept. That's going to tell me my base. And the height, well, that's what the y-intercept is going to tell me. So looking at this, what is my x-intercept? How do I find it? I let y equal 0. So I'm going to let y equal 0. Say 0 equals to -1 on 2e squared bracket x minus 1 plus e squared. Multiply both sides by 2e squared. That's going to give me 0 equals to -1 bracket x minus 1 plus 2e to the 4. But I'm going to run out of room here. Let's see if I can make some room here. And then from here, I can see that that is minus x plus 1 plus 2e to the 4 equals to x. So here I'm just going to push the x over to the left-hand side. X equals to 1 plus 2e to the 4. Okay, there you go. There's a expression for, oh my goodness, for x. And that's it. That's, I guess, that one done. That's going to be our x-intercept. So I'm just going to label it down here. This ends up becoming 1 plus 2e to the 4, because that's what that is. So it's also the same distance as 0 to that point. Okay. Now the other one that I'll need is this guy, my height, and that's by finding the y-intercept. How do you find a y-intercept? Let x equal to 0. So I'm just going to move this over. Try to make some room for myself. Should probably also move this over up here. This is what happens when you forget to do stuff. Okay, so to find the y-intercept, we let x equal to 0, and using my equation, which I have here, I'm going to say y equals to minus 1 on 2e squared, 0 minus 1 plus e squared. And so seeing that there, that's negative times a negative. That's going to give me my positive. So it's just 1 on 2e squared plus e squared. And I think that's it. There's my y-intercept. And I'm going to write that down here. That becomes 1 on 2e squared plus e squared. And now that I've got it all together, I'm just going to write area equals half, because that's what it's asking for, right? Area of the triangle. So it's going to be half times base, which I now know is 1 plus 2e to the 4. And I'm going to times it by my height, which is 1 on 2e squared plus e squared. Okay, and I'm sure we could spend time here and simplify it and expand that whole thing. But for the time being, I'm happy with that. You would kind of just answer and it would be in units squared, because we're talking about area. Okay, and just double checking, good timing by the way. We've found the area of the triangle that's bound by the normal, which we've shown here, and the x and y axis. So there's the x axis, there's the y axis, there's our nice right angled triangle. Okay, hopefully that helps, and I'll catch you guys in the next one. See you later.